So we have to start writing this additional time.
Yes.
Okay.
Once you are done writing, please type done, okay? But please make neat notes, okay? These are very important points, and using these points only you'll be able to solve the questions. I'll show you use how to use these points. But first, make neat notes, okay?
So what is the full form of FBD?
It's free body diagram.
Okay, sir.
Noted, all of you?
I'm ready the fifth one.
Sir, I'm on
Okay.
pseudo force. Sir, can you scroll a bit up? No, unlike the pseudo force. Yeah, thank you, sir.
Those of you who are done, type done in the comment window. Let me see how many of you have noted it. Just answer this poll, okay, all of you. Once you are done. All of you, please write quickly whether you have done or not. Answer the poll. Seven people have said no. How many of you are still doing?
Sir, 1 minute,
Okay.
last point.
But I'm on last sentence.
हाँ लिखो ऐसे, वहां पे पोल में हाँ ना लिखो भाई. हो गया भाई सबका?
Yes, sir.
चलिए, तो we are not dealing with any non-inertial frame. We will be dealing with this inertial frame only. And we have already discussed these forces, right? Gravitational force, reaction force में normal reaction, friction, tension. और हमने we have also discussed spring force, right? Now it says whenever we have to solve problems in laws of motion, all of you please pay attention बेटा, हाँ बहुत important है. अच्छा, सबको उतना वेक्टर आता है जितने की जरूरत इसमें है. All of you know how to resolve a vector, yes or no?
Yes, sir.
All of you know how to resolve a vector? All of
Yes.
you. Karman Singh Gill, you know how to resolve a vector?
Yes, sir.
What is triangle law of addition of vectors?
Sir, triangle and parallelogram तक पता है, 3D vectors नहीं आते हैं.
Rugved, you know what are parallelogram law of vectors? Vectors resolve करना आता है बेटा?
Sir, I think I was absent last class. I mean, the classes before.
नहीं नहीं, मैंने वेक्टर्स की बात कर रहा हूँ. आई एम टॉकिंग अबाउट वेक्टर्स. आई हैव टॉट यू
Oh,
वेक्टर्स वे बैक.
yes, yes.
ओके, तो ये तो मैंने पूछ लिया इसलिए कि मुझे लगा था कि कोई तो बोलेगा. बट आई एम अवेयर कि ऑल ऑफ यू आर अवेयर ऑफ इट, है ना? वेक्टर सबको आता है. तो चलो, अब मैं तुमको सिखाता हूँ कैसे प्रॉब्लम इसके क्वेश्चंस को सॉल्व करना. तो लेट्स स्टार्ट विथ क्वेश्चन नंबर 1, एग्जांपल 1. ठीक है, एकदम बेसिक क्वेश्चन. फर्स्ट वन, वी हैव अ मास एक ब्लॉक है और वो ग्राउंड पे रखा हुआ. ठीक है, नाउ दिस ब्लॉक is experiencing a force capital F here. ठीक है, a capital force F is applied to this block which is making an angle theta with the horizontal. Okay, mass of the block is m. ठीक है बच्चों, क्वेश्चन में पूछता है फाइंड द एक्सेलरेशन ऑफ द ब्लॉक and the force exerted by the surface by the ground on the block. ये निकालना है आप. ठीक है भाई, तो फर्स्ट स्टेप क्या है? व्हाट इज द फर्स्ट स्टेप? रीड हाउ टू सॉल्व प्रॉब्लम्स में फोर्सेस के बाद जो इनर्शियल नॉन इनर्शियल फ्रेम के बाद फर्स्ट स्टेप क्या है बेटा? ऑल ऑफ यू रीड दैट. आइडेंटिफाई द सिस्टम, बोला है ना उसने।
Yes.
तो उसमें बोलता है द सिस्टम शुड बी सो चोजन सच दैट देयर इज नो रिलेटिव मोशन बिटवीन द बॉडीज। तो यहाँ तो एक ही ऑब्जेक्ट है, बस यही है बस, तो रिलेटिव मोशन का सवाल ही नहीं उठता है। सो दिस ब्लॉक इज द सिस्टम। गॉट इट ऑल ऑफ यू?
Yes, sir.
दिस ब्लॉक इज द सिस्टम। ठीक है, नाउ व्हाट विल यू डू? ड्रॉ द फ्री बॉडी डायग्राम ऑफ दिस ब्लॉक। एफबीडी इज फ्री बॉडी डायग्राम। फ्री बॉडी डायग्राम का मतलब क्या होता है बेटा? हम इसको अलग करते हैं from all the objects with which it is in contact. So the block is now separated from the ground. उसके बाद we see what are the forces acting on it. तो कैपिटल F फोर्स लग रहा है, एक वेट mg लगेगा। देखो वेट कहां से लगा रहा हूं मैं? The mass, the weight will always act at the center of the object, right? तो सेंटर पे टेल है वेक्टर का and the direction of vector is pointing towards the center of earth. That is how weight is plotted. Yes or no? अर्थ ग्रेविटेशनल फोर्स कहाँ लगता है बच्चों? Gravitational force always acts towards the center of the earth. Yes or no? Perpendicular to the ground.
Yes.
Right? Now here, normal reaction acts at this point, right? Normal reaction is the force exerted by the ground on the block. This is the normal reaction. Understood, all of you? Say yes or no.
Yes, sir.
Yes, sir.
तो ये लग गया,
Yes.
ठीक है? तो अब इसको यहाँ वापस ले आता हूँ। Now, what is the next step? So we have drawn all the forces. I have taught you 4 forces. There is no spring, so there is no spring force. There is no string, so there is no tension. Normal reaction and mg. और एक external force जो F लग रहा है तो पहले से लग रहा है. Okay? All of you understood? Anybody is having any doubts in this? Please ask. See, it is very
No,
important
sir.
to understand these forces, right? That's why I am teaching you from the
Sir.
very basics. Now, what is the next step? Harshita, what is the next step?
That to resolve the forces.
और उसमें क्या लिखा है और आगे लिखा है कुछ देखो।
So to resolve the forces along the probable or actual direction of the motion
और भी लिखा है आगे।
and perpendicular to it.
हाँ, तो see, this block is not losing contact with the ground. This block is not losing contact with the ground. So what is the direction of motion of this block when it is applied by this force? What is the direction of motion of the block? Tell me. All of you, tell me, what is the direction of motion of the block?
Along the x-axis.
Obviously along the x-axis, right? So that is the probable or actual direction of motion of the block. So this is the direction of motion of the block. All of you understood this?
Yes, sir.
Now the other direction will be perpendicular to it, because a vector is resolved along mutually two perpendicular lines. Remember, वेक्टर हमेशा दो परपेंडिकुलर लाइंस के along रिजॉल्व होता है, याद है कि नहीं है? All of you.
Yes.
So if we
Yes,
know
sir.
one direction, the other direction should be perpendicular. That's it. Now tell me, is n needs to be resolved? Do we need to resolve n or mg?
Yes. Yes, sir.
No, we need not have to resolve. They are already along the perpendicular direction. क्यों resolve करना है? You have to resolve only that force which is not along these lines. The yellow lines I am talking about. Got it? So which force is not along these lines?
F.
F. So you have to resolve F. तो कैसे resolve करोगे? This is F. This is F का component, right? This component is F cos theta. This component is F sin theta. I hope all of you understood this. Yes or no?
Yes.
Anyone is having any challenge in understanding the components of the forces? Please ask. Karman Singh Gill, camera on. मैंने अगली बार कैमरा तेरा बंद देखा तुझे मैं बाहर कर दूंगा बेटा, मीटिंग रूम में बैठना है तो आराम करना, ठीक है? और ये तो मेरे को समझाना ही मत कि सर ग्लिच हो रहा है, ये हो रहा है, वो हो रहा है। तो ये है, ठीक है, ऑल ऑफ यू। नाउ
Sir, camera is
नाउ
on.
अब ऑन है। तो नाउ आफ्टर दिस व्हाट इज द नेक्स्ट स्टेप? Jiashini, tell me the next step after we have resolved the forces.
So after that, we have to solve the force equation.
नहीं, check the steps now, you have written it.
Sir, we have to write the equation.
Write force equations. What was the force equation? Force equation was the second equation of motion. Force F is equal to mass into acceleration. This is the force equation. तो इसमें क्या होगा? We have to see the net force in the forward direction. First of all, let's see the net force acting in the forward direction along positive x-axis. What is the net force acting along positive x-axis? Kavish Shah, tell me what is the net force acting along positive x-axis?
Sir, F cos theta.
F cos theta. There is no other force acting along horizontal direction. The only force which is acting along horizontal is F cos theta. So this is equal to mass of the object multiplied by acceleration of the object. Got it? So from here
Sir.
we got the acceleration of the object is F cos theta upon m. हाँ बोलो.
Sir, will there not be any friction?
There is no friction. I haven't taught you about friction. Friction,
Oh.
this is a smooth surface, right? When friction will come, I'll tell you about that. So there is an entire chapter on friction. Till the time I mention friction, don't assume that there is friction, okay?
Oh, okay, sir.
This is a smooth surface. Okay. Now this is acceleration. A is equal to F cos theta by m. Now, all of you, tell me what is the net force acting upwards? Jiashini, tell me the net force acting perpendicular upwards.
Theta.
Sorry,
F sin theta.
I said F net force. If you are here, this is you, right? If somebody pulls you upwards with a force of say 15 Newton, pull you downwards with someone is pulling you with a force of 5 Newton, someone is pulling you downwards with a force of 2 Newton. What is the net force acting upwards, Jiashini?
Sin theta minus in
अरे इधर इसमें.
here.
हाँ. What is the net force acting upwards on you? Did you hear the question? अनम्यूट बेटा, अनम्यूट करना उसको. Unmute. Without unmuting, how can I hear? No, now you are not audible. चलो छोड़ दो. कौन है भाई? रुको जरा. ऋग्वेद माने.
Yes, sir.
ये तुम हो. This is you, right? ये तुम्हारे ऊपर किसी ने force, someone is pulling you upwards with a force of 15 newtons, right? You can see that. Someone is pulling you downwards with a force of 2 Newton. At the same time, someone is pulling you downwards with a force of 2 Newton. What is the net force acting on you in the upward direction, Rugved?
8 Newton.
8 Newton. How did you come across this 8 Newton figure?
Sir, 5 and 2 को ऐड किया फिर सबट्रैक्ट किया.
15 Newton minus 5 Newton minus 2 Newton. This is how you got 8
Yes.
Newton, right? So in this block,
Yes.
on this block, what is the net force acting upwards, Rugved?
Sir, am I audible now?
Yeah, you are audible now. But wait. Yes, Rugved. Tell me, what is the net force acting on this
Force
block
दिया
in the
नहीं
upward
है
direction? अरे फोर्स दिया है ना. नॉर्मल रिएक्शन फोर्स होता है कि नहीं होता है बेटा? ऋग्वेद, नॉर्मल रिएक्शन इज फोर्स और नॉट? mg इज फोर्स और नॉट?
Yes, gravity.
ग्रेविटी, f sin थीटा इज फोर्स और नॉट?
Yes.
Obviously, yes. So there are three forces acting. You have to tell me the net force. The way you calculated this force, similarly, you tell me in terms of F sin theta, N and mg only.
F sin theta minus mg
और पूरा बोलो, ध्यान से देखो वहां पर
और
क्या क्या है.
F cos थीटा का क्या होगा फिर?
कॉस थीटा तो फॉरवर्ड लग गया यार, मैं वर्टिकल अपवर्ड डायरेक्शन की बात कर रहा हूँ. कितने फोर्स लग रहे हैं बेटा वहां अपवर्ड्स? नेट फोर्स कितना लग रहा है
F
वहां,
sin
नेट
थीटा
फोर्स?
माइनस mg.
और एन क्या कर रहा है बेटा, हलवा खाने आया है यहाँ पर.
ओ
चार
N.
बार बोल डाला मैंने, एन है वहां पर, एन है
हाँ.
वहां पर, चार बार बोला है मैंने. फिर से बोलो, व्हाट इज नेट फोर्स एक्टिंग अपवर्ड्स?
N plus F sin theta minus mg.
Yes, it's n plus f sin theta minus mg. This is the net force acting upwards. This equated to, the block is not moving up. There is no acceleration upward, so it is equal to zero. Mass into acceleration. Mass is m, but acceleration is zero along y-axis, so it is zero. So from here we get n as mg minus f sin theta. I hope all of you understood this. Yes or no?
Yes, sir.
Normal reaction समझ आया? Subhaditya, you understood normal reaction?
Yes, sir.
Harshita,
Yes, sir.
Gurudeep, net force. You understood how to write net force, Gurudeep?
Sir, understood.
Okay. Jiashini, Hariharan, Man.
Yes, sir.
Okay.
Yes, sir.
लिखो इसको जल्दी से. All of you write it.
So can you explain the part where it says the n plus f sin theta minus mg is equal to mass times 0?
What do you want me to explain? See,
Like the
the
mass
way we
times
wrote,
0.
this expression. What was this expression? Tell me. Why we wrote this?
So force is equal to mass times acceleration.
First of all, understand there is a force equation, right? On the left hand side, all of you please pay attention. On the left hand side, we write net force. On the left hand side, we write net force and then equate it to mass into acceleration along that direction in which the force is acting. Okay.
Oh, okay.
So now in this case, horizontal direction mein the force acting was F cos theta. Yes or no?
Yes, sir.
So I wrote F cos theta is equal to mass into acceleration along horizontal direction. That's why I made this acceleration along horizontal direction. Yes or no?
Oh, yes, sir. Oh, now I
So
understand, sir. Thank
simple.
So done.
Done, sir.
Chalo. If you are done, if you have noted it, I am giving you one question to solve. Try doing that question, all of you. Now, this is an inclined plane. This is an inclined plane. All of you are aware about an inclined plane, right? And this is the angle of the inclined plane. It is inclined at an angle theta. There is a block on this inclined plane, right? There is no friction anywhere, right? Till the time I see there is friction, assume that there is no friction anywhere, okay? Every surface is smooth surface. Now this block was released. This block was released at time t is equal to 0. Okay. You have to find the acceleration of the block immediately after it is released. What is the acceleration of the block? First question is find the acceleration of the block when it starts sliding on the inclined plane. And second क्या है? Find the force exerted by the inclined plane on the block. All of you, try it. It's a very simple question. करो इसको. Same process, same method. Okay, Tanushri, समझ आ रहा है बेटा?
Yes, sir.
Okay, good.
Well done.
चलो, I hope all of you have attempted it, at least tried attempting it. Karman, done. Shubhadit, हो गया सबसे? कर ली? All of you done?
Yes, sir.
Okay. चलो आओ बेटा, इधर देखो सब लोग कैसे करेंगे. How to solve this question? Gurudeep, what is your take in this? Tell me how to move ahead.
But now only I am writing the question.
Sorry?
I didn't start to solve, sir.
Why?
Actually, I am writing the question.
Arey, don't
Drawing the
write it. See, don't write. मतलब just draw the diagram and start solving. You have the recordings, na? Why you are
yes,
wasting your time in writing the question?
yes, sir.
Chalo, take 2 more minutes. Solve it quickly.
Sir, is my answer correct?
तुम्हारा फोर्स गलत है भाई. ठीक है.
Okay, sir.
हम्म. चलो आओ इधर देखते हैं. This is mg. All of you pay attention. This is mg. This is normal reaction. Only two forces are acting here, right? mg and normal reaction. So free system choose kiya. What was the system here? System was this block. Okay. Now after the system is chosen, we drew the free body diagram. All of you understood where the vector is, where the tail of vector is. The tail of vector is at the center of the block. Here the tail of vector is at this point. All of you understood or not? Say yes or no. Hello.
Yes.
Right. Now after this, what we are doing is we will resolve the forces along the probable or actual direction of motion. So there is an actual direction of motion along the incline, down the incline, right? So draw this line. The other line is perpendicular to it. Okay. So which force needs to be resolved? N or mg?
MG.
mg. Very good. So mg को resolve करने के लिए क्या करेंगे? This is mg and this is mg, right? mg का component, sorry. So these are the two components. If this is theta, see here, if this is theta, this angle will be 90 minus theta. Yes or no?
Yes.
So this angle will be theta. Yes or no? शुभादित्य, ऋग्वेद, हर्षिता, समझ आ रहा है बेटा? गुरुदीप, understood or not?
Yes, sir.
Yes, sir.
So all of you understood which is theta? This angle is theta. Okay. So this angle, this component is mg cos of theta. So automatically this component will be mg sin theta. I hope all of you understood how to resolve a vector. Yes or no? अरे बोलो
Yes,
हाँ या
sir.
ना, समझ आ रहा है नहीं आ रहा है?
Yes, sir.
Understood.
मान मान
यस सर।
समझ आ रहा है नहीं आ रहा बेटा तेरे
हाँ सर आ रहा है अभी।
को? चलो, तो this block will slide down the incline, right? So in this direction the acceleration is a. So net force downwards, करमन सिंह गिल बताइए नेट फोर्स डाउनवर्ड्स कितना है डाउन द इंक्लाइन?
mg sin theta, sir.
Yes, very good. It's mg sin theta. This should be equated to Karman.
So could you repeat?
इसको किसके साथ इक्वेट करेंगे? F net is equal to what in force equations?
0.
अरे मास इनटू एक्सीलरेशन बे, जीरो क्यों होगा? नीचे जा रहा है कि नहीं जा रहा है वो बेटा? क्या कॉम तू सो रहा है क्या? अरे भाई इतना
No,
सिंपल,
sir.
मतलब फोर्स को मास से इक्वेट करना, मास इनटू एक्सीलरेशन से, इसको कितनी बार बताना पड़ेगा मुझे? एक्सीलरेशन इज g sin theta, right? Now in this direction there is no acceleration. There is no acceleration perpendicular to the incline. There is no direction, no acceleration perpendicular to the incline. Om Deshmukh, tell me what is the net force acting in this direction?
Mm, in that direction, it will be N
Net
M
force.
minus.
I talked about net force. Understood? Tell
Yes,
me.
zero.
पहले फोर्स इक्वेशन, पहले फोर्स तो लिख, फिर इक्वेट टू जीरो.
Oh, so N minus mg cos theta is equals to 0.
Yes, it's n minus mg cos theta is the net force, right? Now this has to be equated to what? Mass into acceleration along this direction, which is zero. Got it? Everybody understood how to get this one? So n is equal to mg cos of theta. समझ आया
Yes,
नहीं
sir.
आया? हेलो.
Yes.
Yes, sir.
ओके, चलो. Everybody noted it?
So 1 minute.
Write it quickly. इसमें लिखने का क्या
Two
है?
minutes.
मतलब all of you are aware how to solve it. Solve it ना आगे.
Sir, done.
चलो, तो I am giving you some homework from HC Verma for tomorrow's session. ठीक है? So read this chapter forces, ये वाला chapter जो है, ठीक है? Laws of motion करके एक chapter है इसमें. Please read this chapter. Start reading it, okay? Now, for tomorrow's session, क्वेश्चन नंबर 7 सॉल्व करना है आप लोगों को, ठीक है? क्वेश्चन नंबर 7। क्वेश्चन नंबर 1 एक्सरसाइजेस का, ऑल ऑफ यू पे अटेंशन। एक्सरसाइजेस में क्वेश्चन नंबर 1, 2 एंड 7। ओके, इतना सॉल्व करो, कल मिलेंगे, ठीक है? और फिर कल यहां से आगे बढ़ेंगे। ओके, बट प्लीज रिवाइज व्हाट वी हैव डन टुडे, those statement, those algorithm, that algorithm you should memorize, that algorithm, how to solve problems in laws of motion. Okay, please memorize it, it is very important. ठीक है, चलो बाय बच्चों, गुड नाइट,
Bye, sir.
थैंक यू।
Right.